Welcome to the Deep Dive. Today we're plunging into a world where the future of AI isn't just being written, it's being rewritten. Not by a handful of tech giants, but potentially by a global network. Let's think about this for a second. Training the really cutting-edge AI models, the ones with trillions of parameters. It costs billions. Just astronomical computational expenses, so immense that only a select few corporations can even afford to play. It's created this staggering oligopoly of intelligence, really. But what if that bottleneck could actually be broken? Our deep dive today is all about this fascinating project called IOTA that's Incentivized Orchestrated Training Architecture. It operates as Bittensor Subnet 9. And its mission, it's audacious to fundamentally transform how these state-of-the-art AI models get built by basically completely decentralizing the whole process. So our goal for you today as your guides is to really cut through the complexity. We've been digging into this in-depth investment analysis report on IoT. We'll explore its genuinely innovative technology, its incredibly ambitious vision, and also, crucially, the significant risks it faces. We have to talk about those. By the end of this, you should have a really clear understanding of what makes IOTA such a high-stakes, high-potential player in this whole decentralized AI landscape. It's moving fast.
Yeah, and what's great about this deep dive is that we're not just working off a white paper or marketing material. Our insights come directly from a pretty comprehensive investment analysis, so that gives us a really granular look. Not just the tech specs, but the strategy, the actual strength, weaknesses, opportunities, threats, the real-world stuff.
Okay, so let's set the stage first. There's this foundational concept in AI research. People often call it the bitter lesson. Have you heard of this?
Oh, yeah.
It's this idea that, repeatedly throughout AI history, the most effective path forward wasn't always clever algorithms or some elegant theory. It turned out to be general methods that just leverage massive computation, like sheer scale.
Brute force wins, basically.
Pretty much. Brute force and scale often triumph over, initial design elegance. It's like always betting on the faster chip, even if a software trick seemed smarter at first.
And if you connect that dot to today, the current reality of AI development flows directly from that lesson. Only a few hyperscale corporations, your Googles, Microsofts, Metas, they're the only ones who can really afford the giant data centers and the specialized hardware needed for those trillion parameter models, which creates, like you said, this centralized oligopoly on the cutting edge of AI. We often call it the GPU memory wall. It's just this huge barrier.
The GPU memory wall.
Right.
But that centralized power really sets the stage for what IoT is trying to do, doesn't it?
Yeah.
Because if decentralization is the goal, surely others have tried to chip away at that memory wall before. Let's unpack this. What were the main failures or limitations of those earlier attempts?
Oh, absolutely. Many have tried, and for good reason. One common approach was data parallelism, but the big limitation there was the need for the entire model plus its huge optimizer states to be copied onto every single machine participating. And while that's robust if one machine is slow, it demanded just immense VRAM. For the big run-tier models, that immediately meant enterprise-grade servers. We're talking like 8 H100s.
So much for democratization.
Exactly. It totally undermined any real hope of broad participation if you needed, a supercomputer in your basement.
Yeah.
Then you had folks try model or pipeline parallelism. These methods tried to fix the single-node memory issue by splitting the model itself up. Different workers handle different layers.
That sounds logical.
It does. But the traditional ways of doing it were just incredibly brittle. They needed perfect, high-bandwidth connections. Because a single slow or failed node, what they call a straggler, could just stall the entire training pipeline.
Which is not going to work over the regular internet.
Not at all. Unreliable connections, nodes dropping off. It's just not suited for that kind of environment. And even Bittensor's own original Subnet 9 back in August 2024. It successfully did decentralized LLM pre-training, which was a feat. But it had some fundamental design issues. It was competitive, a winner-takes-all kind of incentive setup, which actually discouraged miners from cooperating. And critically, it still hit those VRAM limits because, just like data parallelism, each miner was training a whole model locally. It wasn't really collective.
Okay, so if those previous attempts hit walls, VRAM, network issues, bad incentives, what makes IOTA different? What's the radical step they're taking? Because decentralized AI training isn't a brand new phrase.
Yeah, it's a fundamental redesign, a real strategic pivot. IOTA aims to transform those isolated competitors into a single cooperating unit. That's the goal, to collaboratively pre-train one single massive AI model together.
A single model.
Yes, and the core value proposition is enabling models way larger than the VRAM of any single participant. By partitioning the model across the swarm of miners, the total size of the AI can theoretically scale with the number of participants. The ambition is huge. Truly democratize access to frontier AI by tapping into what they call a cluster of the whole internet, not just one company's data center.
Wow. So it's not just a technical challenge, it's almost like a profound social experiment too,
Yeah.
right? Moving from that zero-sum winner-takes-all game to something where the whole network wins only if everyone cooperates. That's a massive shift.
It really is. And you're right, its success hinges completely on how robust its economic model is at enforcing and rewarding that cooperation, which is why this key unreleased component we need to talk about later is so absolutely critical. It's kind of the missing piece for truly strong incentives right now.
Okay, we'll definitely circle back to that.
And actually, another point worth mentioning here, it's almost an unfortunate own goal, the name itself, IOTA.
Oh, yeah.
It creates immediate and, frankly, significant market confusion with the IoT Tangle project, which is totally separate, well-established crypto. It just muddies the water, pollutes search results. It makes brand clarity really tough, just adds unnecessary friction, you know?
That's not ideal.
Yeah.
Okay,
Yeah.
well, let's dive into the mechanics first. How does this whole system actually work? You mentioned a hub-and-spoke model.
Right. So the IOTA architecture is built on this hub-and-spoke idea. 3 core roles, each vital. First, you've got the orchestrator. This is the central hub. And crucially, right now, it's controlled by the Macrocosmos team, the developers.
The central point, okay.
Its role is like a conductor. It monitors the network, assigns specific model layers to the miners, manages the whole training lifecycle, and triggers the crucial step of merging the weights together. Now, the team justifies this centralization, especially early on, saying it's needed to enforce incentives, audit behavior, keep the system stable.
Makes sense initially, maybe. And the spokes.
Those are the miners. They're the compute providers, doing the actual heavy lifting. Each miner gets assigned a specific slice of the large language model, usually a few consecutive layers. They receive activations, that's the data flowing through the network from the upstream miner, process it with their layers, and then pass it downstream. This layer-wise division is the key thing that lets the total model size get bigger than any single miner's VRAM.
Got it. Distributed work. And the third role.
That's the validators. Their job is basically quality control, ensuring the integrity of the work the miners are doing. They do this mainly through computational reproducibility. So they'll randomly pick a miner, rerun a part of their calculations, and compare results, checking for honesty, accuracy, like a distributed audit team.
Okay, so the orchestrator, the conductor, triggers this cycle. What does that cycle look like?
It's a 4-stage cycle. Training, then compressed sharing, full synchronization, and finally, validation. That loop repeats.
All right, so that's the structure. The orchestrator, miners, validators, this 4-stage cycle. But how do they actually pull this off technologically? What are the core innovations that make this whole cluster of the whole internet idea even possible? Because this is where it gets really interesting, right? The breakthroughs.
Exactly. This is the clever stuff. The first big one is swarm and incentivized pipeline parallelism. This is their core idea for splitting the model across lots of nodes. It builds on traditional pipeline parallelism but makes it dynamic. It creates randomized routes for data to flow through the network of miners, and this is absolutely critical because it provides resilience.
Resilience
Against common faults, nodes dropping out, and those stragglers, the slow nodes we talked about. This makes the system actually workable over the unpredictable open internet. Okay, second big innovation, activation compression. In any pipeline system, sending activations between nodes is a huge bottleneck. These data tensors are massive.
Right, lots of data flying around.
Tons. So IOTA introduced a novel bottleneck transformer block based on the Llama 3 architecture, actually. It achieves up to, get this, 128x compression of these activation tensors.
128x.
Yeah. So it can shrink, say, 2048 dimensions down to just 32. It uses BF16 precision, which is a smart choice for balancing memory and range. And crucially, it does this while keeping the residual connections intact. Those are vital for training deep networks properly. Early experiments show minimal performance loss, which, if it holds up at scale, is a massive breakthrough, turning a data fire hose into a trickle without losing the important stuff.
That sounds incredibly useful. What's the third one?
Third is butterfly all reduce. So after miners do their local training updates, their new model weights have to be merged together into one coherent global model. IOTA uses this decentralized, trustless method called butterfly all reduce. It achieves O1 bandwidth complexity,
Meaning?
meaning the amount of data each miner has to send during this merge step doesn't grow no matter how many more miners join the network.
That's huge for scaling.
Monumental. It means it can scale, theoretically, indefinitely. It also builds in massive redundancy, which implicitly cross-verifies the work everyone's doing. And simulations show it can tolerate up to 35% failure rates among the nodes during the merge process. That's incredibly robust for a decentralized system.
Okay, that's impressive robustness. And the final pillar.
And finally, the fourth one, HU as SP, stands for Contribution Loss Assessment via Sampling of Pathways. Now, this is the absolutely crucial plan, and this is a big but not yet implemented system for fair credit attribution.
Ah, the one you mentioned earlier.
The very same. It's inspired by Shapley values from cooperative game theory. The goal is to precisely measure each miner's actual marginal contribution to the model's improvement. The idea is that validators can then use this information to identify and properly reward the high-value contributors and also critically detect and penalize bad actors, like free riders just collecting rewards, or worse, data poisoners trying to sabotage the model.
So CalASP is the linchpin for fairness and security, the mechanism to make the cooperation actually work long-term. But you keep emphasizing it's not yet implemented. That sounds, well, like a gaping vulnerability right now. How are they even managing incentives before that piece is in place? Is it just like trust? Or is there some stopgap measure?
You've absolutely hit on a critical point there. Its absence at launch is a material vulnerability. Currently, the incentives rely more on, let's say, reputation, the inherent trust within a pretty new network, maybe some off-chain coordination, rather than a fully baked, cryptographically enforced, granular attribution system like CalASP promises. It definitely creates a trust me period, as you put it. The risk of free riding or even subtle data poisoning is just inherently higher until CalASP is fully operational and proven. It's really the difference between having this highly sophisticated, self-correcting organism versus one that still needs a lot of manual oversight and, frankly, goodwill from participants.
Okay, so it sounds like a potential marvel of engineering, truly ambitious stuff. But, every big innovation has its potential Achilles heel, right? Despite all this impressive tech, what are the biggest red flags? What are the significant challenges and risks IOTA is facing right now?
Absolutely. There are definitely risks. One really prominent weakness, I think, is the hardware contradiction. The project often talks about, welcoming consumer-grade GPUs. Sounds great for democratization, right?
Yeah, opens it up to everyone.
Except the official mining guides explicitly state that miners need GPUs with at least 80 gigabytes of VRAM, and they specify A100 class or higher hardware.
And A100, that's not consumer grade, that's serious enterprise hardware.
Exactly. And A100 is an extremely high-end, expensive data center GPU. So this directly undermines that whole democratization story. It heavily limits the potential miner pool to basically well-capitalized entities, which kind of restricts true decentralization from the hardware side.
Okay, that's a big one. What else?
Another major risk is the architectural centralization we touched on, that team-controlled orchestrator. It's a critical single point of failure and, let's be honest, control, which runs directly counter to the whole ethos of decentralization.
And no plan to decentralize it yet.
Well, there's no clear public roadmap for its decentralization. That's a significant concern for a project that's built its identity on decentralized principles. Then there's the unclear financial standing. Macrocosmos AI, the developer team. Despite being quite large, highly skilled, over 20 people, multiple PhDs, it's listed as unfunded on some platforms.
Unfunded, how does that work?
Right. It raises serious questions about their financial runway. How are they funding this large, extinct team? Is there potential future dilution for investors coming down the line? It lacks transparency.
And the name confusion.
Yeah, we mentioned it, but the brand confusion is a real practical problem. Clashing with IOTA Tangle, it creates market confusion, messes up search results, makes it harder for people to understand what's what. It's just an unnecessary own goal.
Okay, what else is on the risk list?
Well, there's significant execution and roadmap risk. Like we keep saying, key components like CLA-SP aren't there yet. That leaves the current incentive model incomplete, potentially vulnerable. Delivering on that complex roadmap is a huge challenge. And finally, you absolutely cannot ignore the intense competition. IOTA is fighting on multiple fronts. You've got the centralized giants, AWS, Azure, Google Cloud. You've got other Bittensor subnets competing for the same TAO rewards, like
Yeah.
fine-tuning, and then external decentralized competitors too, like Gensen focusing specifically on training, or Akash and Render Network for more general GPU compute. It's a fierce battle out there for TAO stake and for the actual compute resources.
Okay, let's switch gears slightly and talk about the money, the economics. Because even with amazing tech, if the incentives aren't structured right, the whole thing could just fizzle out. How does IOTA, as a decentralized project, actually make its economic engine hum, especially within that broader Bittensor ecosystem? It's not like a normal company selling stuff.
That's a really crucial distinction, yeah. IoT doesn't have its own separate token. It lives or dies by competing for Bittensor's native currency, the TAO emissions. The amount of TAO that gets allocated to Subnet 9 and therefore gets distributed to its miners and validators depends entirely on how much TAO is staked on Subnet 9 by token holders.
So the stakers are voting with their tokens.
Exactly. They're effectively voting with their TAO, signaling which subnets they think are providing the most value to the overall Bittensor network. And value, in this case, accrues to TAO primarily through the utility of the AI model that IOTA eventually produces. If they produce a high-quality, valuable model, it'll attract developers and users who want to build on it or use it.
Right.
This increased utility then makes Subnet 9 look more attractive, so more TAO stakers are likely to delegate their stake there, which directs more TAO emissions to the subnet. This creates a really powerful direct network effect. More miners leads to potentially a better model, which attracts more stake, which means higher rewards, which in turn attracts more miners. It's designed to be a self-reinforcing loop.
A virtuous cycle, if it works.
If it works, yes. And there's also an indirect network effect. If IOTA produces a valuable, maybe open source model that attracts more developers and applications from outside the immediate ecosystem, that enhances the model's overall utility and value, making Subnet 9 even more attractive for those TAO stakers. The key partners here are obviously Macrocosmos AI, the devs, but also potentially platforms like Hugging Face for model distribution, data providers, and the miners themselves. And the primary stakeholders, the ones really with skin in the game. It's the miners supplying compute, the validators providing security, and the TAO stakers providing the capital and the crucial value signal.
Okay, so bringing it all together then. Based on everything we've discussed, the tech, the risks, the economics, what's the overall investment conclusion from the analysis? It really sounds like IoT is a textbook case of high risk, high reward, doesn't it?
Yeah.
Given how ambitious and novel this whole approach is.
That is precisely the sentiment, yes. The analysis clearly highlights the strengths. A genuinely innovative architecture tackling a huge problem, a really elite team with deep expertise, and a very clear problem solution fit for the issues in centralized AI. But, and it's a big but, these strengths are heavily counterweighted by those significant risks we laid out. The centralized orchestrator is a big one. The currently unclear, maybe unfunded status, the absolutely critical missing CLI-LSP mechanism, that persistent brand confusion, the fierce competition, and the surprisingly high hardware requirements. It's a long list.
So where does that leave the recommendation?
The investment analysis concludes with a recommendation of neutral to cautiously favorable, and it's very explicit. This is suitable only for investors with a very high risk tolerance. You need a long-term view, almost like a venture capital investment horizon. It's framed much more as a high potential R&D effort right now, rather than a mature, de-risked investment opportunity.
Okay, that makes sense. But is there a path to becoming more favorable? What needs to happen?
Yes. Crucially, the analysis lists specific, measurable milestones that would shift the assessment towards highly favorable. First, simply demonstrated performance. The network needs to prove it can operate stably at scale and actually produce a verifiably high-quality AI model. Show, don't just tell.
Proof is in the pudding.
Exactly. Second, the successful delivery of CLI-LSP. Implementing that core security and fairness mechanism is basically non-negotiable for long-term health and trust. Third, a path to decentralization. They need to put out a credible public roadmap for eventually decentralizing that orchestrator. It's essential to align with their own decentralization ethos. And fourth, financial clarity. They need to either secure significant external funding or transparently explain their long-term financial strategy to alleviate those concerns about their operational runway.
So quite a few hurdles still to clear. And there you have it. IOTA's incredibly bold ambition to democratize AI training. It's really ingenious technical solutions trying to push the boundaries of distributed computing. And those very real significant hurdles it still needs to overcome. Understanding a project like this, I think, is so important for anyone interested in the future of AI or decentralized tech, or even just how massive, complex digital things might be built and governed differently in the future.
It really makes you think, doesn't it? And maybe this is the final thought for you, the listener, to ponder on. Given the immense complexity and, frankly, the sheer ambition of a project like IOTA, what does it truly tell us about the future of decentralized collaboration? Not just for AI, but maybe for tackling any frontier scale challenge where centralized approaches are currently the only game in town. Can this cluster of the whole internet model really outcompete the centralized tech giants in the long run?